Hi everyone. Today we're going to look at series and parallel circuits. But before we get started, I'd like you to pause the video, go away, find somewhere quiet for you to work. Today you're going to need your knowledge organizer, your learning session, a pen, a piece of paper, and you're also going to need access to a website which is linked in your learning session. Once you're ready to go, please press play again on the video. Okay, so now that we're all set up and we're ready to go, like I said, today we're looking at series and parallel circuits. Our learning objective today is to know the rules about series circuits and parallel circuits. And like I said, this is part of our electricity chapter, so our second chapter in physics paper 1. You may want to pause the video now, write down your date and your LO. Okay, so let's start with our retrieval. So pause the video and give yourself 5 minutes to answer the following 5 questions. All right, let's see how you got on. Hopefully you got 5 out of 5. So get your green pen in your hand. What is our unit of current? That is the ampere, or you might just write it down as amps, A-M-P-S, and our symbol for that is a capital A. This question was revising our first chapter on energy in paper 1. So what equation links kinetic energy, mass and velocity? So that's kinetic energy is equal to half multiplied by mass multiplied by velocity squared. Question 3, what is the unit of potential difference? That is our volts, and again our symbol for volts is a capital V. What do we measure resistance in? And we measure that in ohms, and your symbol is there for you. So that's the symbol omega. So it's almost like an O with 2 little feet. And question 5, what equation links current, resistance and potential difference? So that is resistance is equal to potential difference divided by current. So you might want to pause the video at this point and give yourself a second to just mark your answers. Hopefully we all got 5 out of 5 on that one. Okay, so like I said, today we're looking at series and parallel circuits. We want to investigate the current and potential difference in both. We want to be able to explain the current and potential difference rules for both series and parallel circuits. And we basically want to be able to compare and contrast both types of circuits. So your very first task, it's your first task on your learning session, is to explain what electric current and potential difference in a circuit mean. So pause the video and give yourself a minute to write down your answer. And as a challenge, if you would like to write down what resistance means as well. All right, so what is current? So our electric current is the flow of electrical charge going through a circuit, and we measure it in amperes, or as we said, amps, and our symbol is a capital A. What is potential difference? So that is between 2 points is the amount of energy transferred per coulomb of charge that passes between 2 points. So let's just read that one again. Potential difference between 2 points is the amount of energy transferred per coulomb of charge that passes between 2 points. So basically the amount of charge that is going to pass between 2 points. And finally, for any of you that try the challenge, resistance is the opposition of flow of electrical charge through a circuit, and we measure it in ohms. And again, our symbol for that is omega. All right, so I hope you're ready to use our link. So I have attached it there above again so you can see it here. It's fet.colorado.edu/sims/latest/circuit-cit/cat-c/dsc/latest/circuit.construction/kit/dc. I have also included this link on your learning session. So take a minute if you haven't already set it up and type that into Google. Just press enter. It should bring you straight to the correct page, and I'll talk you through what you need to do. Okay, so now that you're on the page, what you might find easier is I'd like you to draw each of these circuits into your book. So each of these are my series circuits. So remember, series means one after another. So I watch a series on Netflix, I watch one episode one after another. So we can see that everything follows each other one after another. Okay, and it just goes round in one circuit. So if you draw each of these series circuits into your book, and then I would like you for the first three, using your FET simulation, to figure out the amp meter, so the ampere on each of these. So place in your amp meter at the different locations and see what answers you get. When you've completed that, come back and draw down your three circuits. So remember, our voltmeter always goes parallel, so that's why it looks a little different to our amp meter. And this time you're going to calculate the voltage at this point, and this point. And what I want you to look at is I want you to look and see, is there a difference? Does my current change if I change its position? Or does my voltage change if I change its position on my circuit? Okay, so we're looking at series circuits. So you're going to have to pause the video right now, give yourself maybe 10 minutes to try all 6 of these circuits, and then come back to the video and we'll continue on. Okay, so now you should have taken that time to complete all 6 circuits. You should have jotted down what your amps are for each of the first 3 and what your voltage was for the second 3. So looking at current, does the current flowing through the circuit change if more components are added in series? So you might want to again pause the video, go back to your website, add in more bulbs, add in more resistors, see what happens to your current. What you should see is you should see that the current flows across each component in series is the exact same. You should not see a change in the current. So I want you now, again, pause the video, go back to your link and try out what would happen if 2 filament bulbs were wired in series and one broke. So take one of those bulbs out and do not replace it. See what happens to your current. Okay, this time our potential difference, so our circuits 4 to 6, did the potential difference across the components vary from that across the voltage supply? So when you put the voltmeter in at those different points, did you get a different result? So the total potential difference of the supply is shared between the components. So what you should have seen is that if you inputted a voltage of 12, for example, in your cell, you should have noticed that when you added up all those voltmeter readings, that you got 12 in total. So now I want you to go back, double check that what I'm saying is correct. Don't take my word for it. And then I want you to look at the brightness of the bulbs wired in series. If you change the voltage, what happens to the bulbs? Do both of them change? Does one of them change? Alright, so now that you've had a chance to play around with the website and try, what I want you to do now this time is set up some parallel circuits, doing the exact same as what we've already done. We're now going to log on to our website again. You again might want to just draw these circuits into your book so that you can look at them one at a time. You're going to measure your amps for your parallel circuit, here, here, and here. And again, you're going to do the exact same for your voltmeters. So you're going to measure it here, here, and here. So take a minute, jot down each of your circuits, log back onto your PhET website, and set up your parallel circuits. Jot down your amps for 1 to 3 and jot down your voltage for 4 to 6. Alright, what did you notice this time? Was it the same as the series circuit or was it different? So in summary now, you should be able to answer these 4 questions. So if you look on your learning session under summary activity, this is your first question. So using the 5 words that I've given you there, I'd like you to fill out those 4 questions. So pause the video one more time and fill them out for me. Alright, and before we finish up, I'd like you to answer this exam question. So this is a 6-mark exam question. It's asking you to compare and contrast parallel and series circuits. So what you've just investigated, what you've just learned using that link, you should be able to answer this question. The 6 marks, what you need to include is an example of a circuit diagram for both a series and parallel circuit. You need to describe both circuits. You need an explanation of how the current varies for each type. You need an explanation of how the potential difference varies for each type. And for the last mark, you need to describe and explain what kind of circuit will be best for Christmas lights and why. So in reality, you would have 6 minutes to complete this question in your exam. So if you want to pause the video now, give yourself maybe 10 and we'll work towards 6 over the coming weeks and try and answer this question as best as you can. Remember to include all of those points to get a full 6 marks. Okay, so get your green pens out, and these are where you would have got your 6 marks. So your first mark was giving me 2 simple drawings to show a series and a parallel circuit. So remember, you've done 6 for both, so you could have picked any 2 of those diagrams to show. Excuse me. Your second mark was for a short description of each. So a short description of your series circuit, a short description of your parallel circuit, explaining how the components are in either series or parallel with each other. So thinking back to that explanation that I gave you about them being one after another in our series circuit and in our parallel, how they sit parallel to each other. So that would have got you your second mark. Your third mark was for a simple explanation for current in series and parallel circuits, and your fourth for a simple explanation for potential difference. These 2 marks you should have got by your investigation, by the results of your investigation that you carried out today. Your 5th mark was for an explanation on how parallel circuits allow bulbs to remain lit even if one goes out, whereas series do not. And then your final mark was the description includes an explanation in terms of current flow. So pause the video one last time and use your green pen to mark your answer now. And finally, your plenary, explain to an alien a series and parallel circuit in less than 100 words. Have a